got the screen on, don't you? Alright, here's our first example we're going to look at here. Yes. Right now, I'm getting ready to teach you something that's not all that difficult, but it's going to make you miss half of the problems you've already been able to do so far. So I'll show you why after we get this problem done. It's going to make you do several problems wrong, or at least some of you, because it's easy to get this mixed with something else. Hopefully, by me warning you of that, maybe it won't. But it's not that difficult. It just makes you think all problems work like this, and they don't. So in this case right here, I don't really have, like something in the bottom and the top. So what I'm going to have to do here is I'm going to have to let u be the denominator, 3x minus 2. So that would make du 3 dx. And make sure as you're doing these problems, include the dx. I know you can kind of do it without it and it still makes sense. One of the trainings I went to a couple years ago, that trainer said that on the last year she graded, they were counting off if you didn't have that dx on the setup, on the free response part. So just be in the habit of putting it on there. Put it in your homework every time, because I'm not certain they're going to count off if you leave it off, but they might, and you don't want to miss points just for that when you really know how to do the problem. So, so you need a 3 right here with that dx, and if you put a 3 there, you got to put a 1/3 out here. So that's 3x minus 2, that's your u, and the 3 dx, that's your du. So you have 1/3, the integral of 1 over u du. Now, if I wanted to, I could think of that as u to the -1. What is the integral of 1 over u? It is natural log. Okay, so we'll have 1/3 times the natural log of the absolute value of u plus c. And so this would be 1/3 natural log of the absolute value of 3x minus 2 plus c. That's it. So nothing all that difficult, but let me show you why it makes students miss a lot of problems. Already on your homework, you've had problems that look like this, 1 over 3x minus 2 squared dx. All right, we've already had some of those. So this is what happens when you solve this problem. It's a lot the same. U is 3x minus 2, du is 3x or 3 dx. You put your 3 here, you put your 1/3 out here, and you're going to get the 1/3, the integral of 1 over u squared du. Except for what most students do is they automatically, somehow if they've got something in the denominator, they automatically think that the integral of that is natural log. This problem is not going to be natural log because you've got 1/3. This is u to the -2 du. So that would be 1/3, and then you'd have u to the -1. So you'd have a -1 right here, plus c. So you'd get -1/3 u to the -1 plus c, -1 over 3 times 3x minus 2 plus c. All right. So after I teach you about the natural logs, what I find is that students start, anytime there's anything in the denominator, they say it's a natural log, and it's not necessarily. If it's raised to a power, then you're just using the power rule, like we've been doing before. So watch out for that whenever you have quizzes and tests.
In the denominator, and it doesn't have a power.
Then it's going to be natural log, yes. All right, here's our next one. Got the integral of x squared over x to the third minus 8. In a problem like this, the denominator is almost always your u. Not always, but almost always your u. And especially in this case, you should be thinking, oh, if I take the derivative of x to the third, I get 3x squared. So that right there could be my du right there. So the u for this is x to the third minus 8. So du is 3x squared dx. And you already have the x squared, but what do you need to go with it? 3. And then you got to put a 1/3 on the outside. So you're going to have 1/3 integral of, and then this right here is my u. This stuff up here is du. So you can write it like this, du over u, or if you want, you could do 1 over u times du. It doesn't really make a difference. They're the same. When we integrate du over u, what do we get? Okay. And make sure you put some absolute value bars around that x cubed plus 8, or x cubed minus 8. And then we'll have the plus c in there. Okay. In my opinion, these are almost easier than the ones where you got to do the power rule. But be careful, because not everything with something in the denominator is a power rule. Is a natural log. Okay, questions? All right, here's our next one. Alright, what's the u in this case? It's not the x. Because if I took the derivative of x, I'd just get 1, the x. And then so I'd have that natural log of x, and I wouldn't have anything to replace it. It is. So u, in this case, is natural log of x, and so du is going to be 1 over x dx. And here is the case, a little bit ago I said it's usually the denominator. Here is the case where it's not. If you see that natural log, that's typically, not always, but typically going to be your u in that case. So this natural log of x, that's our u. And then this part right here is your 1 over x dx. So that's your du. So we end up with the integral of u to the third. And so we just have a simple power rule here. So that's going to be u to the 4th power, the 1/4 out front, plus c. And then we're going to plug in our natural log of x to the 4th plus c.
Never mind. Yeah. I was going to ask how the x just becomes the technically kind of like 1 over x.
Right. If you wanted to, you could think of it like this. This is the integral of natural log of x to the 3rd power times 1 over x dx. So that part right there, that part is your du.
Gotcha.
Yeah. If it was in the numerator, it would not be. And then you wouldn't be able to do the problem. If that was the case. All right, questions? All right, I'm going to change this next one. Let's see. I've locked it in place. So let me change this next one. I'm going to change it. Let's unlock that. Let's just make this tangent of theta. Alright, now we know how to integrate secant squared. We know how to take the derivative of tangent, but we do not know how to integrate just tangent, right? Because nothing has a derivative that is tangent. We could integrate cosine, we could integrate sine, we could integrate secant squared, we could integrate cosecant squared, or cosecant cotangent, but we can't integrate just tangent. So we can change it to sine over cosine. And so in this case, we could do, like we could let the u be sine and the du be cosine, or we could do the u as cosine. In this case, we want to choose the denominator because you can't integrate if you have like u over du. The du can't be in the bottom of the fraction. So we want our u to be cosine of theta, which means du would be negative sine of theta, d theta. So we've got the sine, we've got the d theta, we just need a negative right there with it. So we're going to put a negative right there on the inside, and we have to put a negative on the outside. So this cosine right here in the bottom, that's our u. This negative sine theta d theta right here, that's our du. So we end up with negative integral of du over u. What do we get when we integrate du over u? We got to integrate 1 over u. What do you get when you integrate 1 over u? Natural log. So we've got negative natural log of the absolute value of u plus c. And so we're going to get negative natural log of the absolute value of cosine theta plus c. Yeah, you got to be careful with that. So we've held off for a very long time on learning how to integrate tangent because it doesn't integrate easily like sine or cosine. So this is what you want to do if you end up with tangent, or maybe if you had cotangent, it would work pretty much the same way, except for you'd have cosine over sine that you'd start with. Okay, here's our next one. And e's are the easiest, but yet they're still highly, highly missed because we're just not nearly as familiar with e's as we probably should be. So in this case, we know the derivative of e to the x is e to the x, right? The derivative of the integral of e to the x is e to the x. But when you have something besides the x up here, you're going to have to do a u to u substitution. Just like if you're taking the derivative of e to the 3x, you'd have to do a chain rule, right? So our u here is going to be 3x. So that makes du 3 dx. And so with our dx, what do we need? 3 right there. And if we put a 3 here, 1/3 on the outside. So we end up with 1/3 integral of e to the u du. Now here's the one problem where you can get away without taking the integral. The other day whenever Maya didn't integrate on hers, she got the e problem right because the derivative is itself, right? So so when you integrate here, you're not, the integral of e to the u is e to the u. So you got 1/3 e to the u plus c. So you end up with 1/3 e to the 3x plus c. So your e's are the only ones you can really get away with if you don't integrate it. The rest of them will all be wrong. So. Okay, we've got a couple more I want us to look at. Alright, so on this one, what's the u going to be? X squared. Which means our du, 2x dx. Alright, we've already got this x right here, but it's got a 5 with it. Which is a problem because we don't want a 5, we want a 2. So you got a couple options here. If you're really good with fractions, you will know what to multiply it by. What do you multiply it by? 2/5. So you can multiply by 2/5. Because the 5s will cancel and you'll have 2. And if you multiply on the inside by 2/5, what will you multiply on the outside by? 5/2. Okay? I'm just going to show you over here to the side. Your other option is to do this. Just pull the 5 out front. Especially if somehow it's just not working for you there. Just pull the 5 out front because coefficients can go inside or outside. And then you know you need a 2 here, so you'll add a 2 here, and you can add a 1/2 out here. It'll do the same thing. You'll end up with 5/2 on the outside. So either way of thinking there is fine, but if you're having trouble thinking of the right fraction, then that'll help. So we've got 5/2, and then this part right here, this along with the dx, that's our du. And then this part right here, that's our u. So we've got integral of e to the u du, which is going to be 5/2 e to the u plus c. And so we get 5/2 e to the x squared plus c. That's some birthday money. I feel like most people won't realize it, but like I don't know that my other classes will realize it. But you guys are an advanced group. All right. Okay, here's our last one. Wonder if they have Pi Day activities at Disney. Epcot might. Should look into that. Are you gonna be?
I don't know where. I think I'll be at Hollywood Studios.
Really? I bet Epcot probably has, because that's the more educational one, isn't it? I think. But you never know. I feel like Disney might have some activities, possibly.
I'm not there. I will be the only person wearing a holiday shirt.
I bet you won't be with that many people.
I mean, with all those people there.
Yeah. There's got to be another math teacher that is on vacation there.
Yeah.
Yeah. Yeah. Okay. All right, here's our last one. What's your u going to be on this one? It's not. Because, don't write it down, but if I did that, I'd have e to the u over 1 plus e to the u. Do you know how to integrate that? Joe does, but the rest of us.
Can it be e to the 3x because then you can add 1 plus
I'm thinking it's 1z plus 3.
Okay. So if you use e to the 3x, the derivative of that is going to be 3e to the 3x, and the 1 you can't really replace with anything. So use the denominator here for your e. 1 plus e to the 3x.
Well, I couldn't get that out of my I couldn't get it out of my mouth, but that's what I'm saying.
So when you take the derivative of 1, what do you get? Nothing. Then the derivative of e to the 3x is e to the 3x, but you must use the chain rule. So you got to multiply it by the derivative of 3x, which is 3, and then you'll have a dx here. And that e to the 3x is in the numerator, which is where you want your du to be. So you just need to add a 3 right there and a 1/3 out front. So you end up with 1/3 integral, and the stuff in the bottom here is u, and the stuff in the top plus that dx, that's your du. So you get du over u. And when we integrate du over u, what do we get? Natural log of the absolute value of u plus c, and then we just plug in 1 plus e to the 3x. Now, you may see this, e to any number is always positive, correct? So if you add 1 to it, it's still definitely going to be positive. So a lot of times you'll see answer choices where they may not use those absolute value bars on this. My feeling is that on like a free response question, just leave the absolute value bars. Don't chance changing that if it's not really something necessary. But no, if you know for sure that this is going to be positive, if you had something like 1 plus x squared or 1 plus e to the something, then you don't have to put those absolute value bars there. All right, questions? All right, I think this assignment is going to be from the old book. This is not right. Okay, so our assignment today is page 341 still. And we will do 41 through